All right, let's go. Where'd my pen go? Right there. All right, guys, so what'd you find? Anyone, shout out.
A polygon
Is that what?
Two-sided dimensional shape.
Okay, so did you mean two-dimensional shape? Not two-sided.
Yeah.
It's a 2D shape. Okay, guys, so it's a 2D shape. We get somewhat into 3D math in here when we were doing like volumes and stuff, but you don't really get into three-dimensional math until you hit calculus, and then it gets really cool. So right now we're just dealing with flat math, flat surfaces. Yes, it is a 2D shape. Very good. What else did we find? Anything?
All straight lines.
Good. Straight lines. So it's going to have all straight lines. Anything else? Nobody found anything besides that. A closed figure. True.
It's a many-sided shape.
Many-sided? Yeah, we'll have many sides. It has to have more than two.
So literally it's
Must have at least 3 sides. So more than 2 sides.
Must have at least 3 sides.
So triangle or
Right. Anything after a triangle, right? Because 3-sided. We can't have a 2-sided shape. Yes. It won't have curves. True. No curves. Pretty awesome. So do we kind of have an idea of what polygons are then? Okay, awesome. All right, let's get started. Yeah. Pass them this way, and I'll hand them in. Just pass it.
I need that guy. Throw that over here.
All right, so recall that yesterday we were dealing with congruent triangles, and we were using triangle congruence theorems. So we learned that we have angle, side, side, angle, and what's the last one? Angle, side, side, angle, side. Okay, good. So we used those yesterday to prove that triangles were congruent. Today we're going to be dealing with similar polygons. Now we're going to be dealing with polygons, not just triangles, but we are going to have similar triangles today as well. Now similar is different than congruent. Similar is different than congruent, but they do go hand in hand. So first of all, what qualifies 2 or more things to be considered similar polygons? So I'm about to tell you. Similar polygons will have the exact same shape, but they might be a different size. So I'm going to say that again. Similar polygons will have the exact same shape, but they might be a different size. Oftentimes you'll have a small polygon that's still a similar polygon to a really large polygon. Now these are the 3 things that qualify. These are the 3 characteristics that qualify something to be similar polygons. You'll want these things down. So these are the 3 properties of similar polygons. The first one, it's pretty simple, pretty basic, guys. The same number of sides. So if they are similar polygons, they'll have the same number of sides. Pretty straightforward, right? A square is not going to be similar to a triangle. Does that make sense? Pretty easy. The second thing, corresponding angles are congruent. Once again, corresponding angles are congruent, meaning even though we have a small polygon and a large polygon, the angles are going to be equal. Congruent means equal. So just because we have a large polygon and then a small polygon, those angles will be exactly equal. Even though one's large and one's small, angles will be equal, identical. So I have my picture of my identical twins. Identical twins are identical. Their DNA is identical depending on what kind of twins they are. But that's how our 2 polygons are going to be, is they're going to have identical angles. Now the third thing and the most important thing, we're going to be using this a lot today, it's the hardest thing for students to get, is corresponding sides are proportional. Now notice how I said corresponding sides are proportional, not equal. Proportional doesn't mean they're equal. They're not going to be equal most of the time, especially when we have a small polygon and a large polygon. But when we set up corresponding sides as a ratio, the ratios will be the same. So what we're going to do is set up corresponding sides as a ratio, and we'll look to make sure the ratio is the same. Now guys, what corresponding means? Everybody listen carefully. Corresponding means it sits on the different triangles but in the same spot. Okay? So let's look at this bigger triangle versus this smaller triangle. If I told you they were similar, you would know that we could set up a ratio of corresponding sides. So does everybody see how A and B sit in the same spot?
Yeah.
So we could set up a ratio A over D. A over D. Well, that will be equal to the ratio of, does everybody see how B and F sit in the same spot?
Yeah.
Will be equal to B over F.
And then that would be equal to C over E.
Very good. And that will be equal to C over E. Now notice something very important here. I'm going to highlight it real quick. Notice something very important. I went from the big to the small. I always listed the big on top. Does everybody see that?
Yeah.
Now you have to be consistent. We could have listed the small over the big, but we would have had to stay consistent. Does that make sense?
So it doesn't really matter.
It doesn't matter when solving. Yeah, when solving, it doesn't matter as long as you stay consistent. Okay. Any questions on that? Now we're just going to apply it. Here we go. Now you'll need to pay close attention today. This is new. Everybody ready? Here we go. Okay, not yet. Here we go. All right, now before we get started in the practice, you need to know the symbols. So this is the symbol for similar. It's a little squiggly. This is for congruent. We've been doing congruent for a while now, right? Congruent means equal. There's an equal sign with a little similar sign above it. So similar versus congruent. And then corresponding just means, I already talked about it, it sits in the same spot on different triangles or different polygons. But it sits in the same spot. We'll have corresponding sides, corresponding angles, and so on.
So corresponding is just the fact.
It just means it sits in the same spot on each of the polygons. Yeah, good questions. Okay, so similar versus congruent. Today we're dealing with similar polygons. And we know 3 things about similar polygons. All right, here we go. Here's our first problem. All right. It might be more beneficial for you to not try to take notes on this one, but just to watch. Okay? So here it says, given the 2 polygons are similar, so this time we're given that they're similar, find all the missing sides and all the missing angles. So notice I have this small triangle, I have this large triangle. We're told that they're similar. Also, very important, look up here. This is our similarity statement. We're going to use that very heavily, okay? We're going to use that very heavily. So we're told triangle ABC is similar to triangle DEF. So we can look at our similarity statement and tell which angles go with which angles. So let's look at it. First of all, angle A goes with what angle? D. Do you see how it sits in the same spot in the similarity statement? It will also work for, these might not be sitting in the same position. They might be rotated. So you'll use the similarity statement. So we know angle A is equal to or corresponding to angle D. So I'm just writing that down. And then we know that B and E, so angle B is equal to angle E. And we know, and I didn't color coordinate these right necessarily. I shouldn't have switched colors. C is to F, so we know angle C is equal to angle F. Now take my suggestion. When you're asked to find all the missing angles and all the missing sides, find all the angles first, so you don't forget anything, and then find the missing sides next. So let's just worry about angles right now. Let's worry about angles. So look right here. Angle B. We don't have angle B.
68.
Okay, how'd you know angle B was 68?
B and E are the same.
So B and E are the same. So if this is 68, then this is 68. Now I'm going to pause. Questions on why it's 68?
So would it mean that the blue one would be 35?
Yes, good. So, yes. So if this is 35, angle A is equal to angle D. So this must be 35. Similar polygons have equal angles, even if one's big and one's small. So then if this is blank, and this is 77, this must be 77 degrees. Okay, questions on that? Look at our small triangle. Have we filled in all the angles? Look at our large one. Have we filled in all the angles?
Yes.
Okay, awesome. So we can move on. The angles part was easy, right? All right, so now we're to the good stuff. So now, it says, find the missing sides and angles. So now we need to find the missing sides. Look at my small triangle. We have side 10, 6, and 7. We're not missing any sides, right? Okay, but let's look at our big one. 20, 12, and...
The answer is 14.
Okay, but let's do the math behind it, because they're not all going to be this easy.
Because they're half.
Okay, but they're not all going to be this easy, where you can just see it. I promise. There's going to be decimals. So we're going to do the math to get there. Which you are doing the math. Okay.
7 times 2 is 14. 10 times 2 is 20. 6 times 2 is 30. Amen.
Okay. You're right. It is going to be 14. But I promise you're not going to just be able to see them all. So let's go through the math, okay? Well, that's what we're going to do. Are you ready? Okay. So we know we can set up a ratio of corresponding sides. So let's look at side, let's look at side AB. AB is to what side? AB, DE. So AB is to DE. So I'm going to put a tick mark there. Is everybody okay with that?
Yes.
So these are corresponding sides. We can tell from the similarity statement. Let's set up a ratio of those things.
So
10 over
20.
20
Or 20 over 10.
or 20 over 10, but we'll just stay consistent. We would get the same answer in the end.
So
Can we keep going and then I'll see if you have it still in the end? Or does it pertain to this right now? Okay, yeah.
So if you put 20 over 10 and divide it, you just use that number to times by the other.
Yes, that's yes. I'm going to keep going this way. Yes, that is one way. Okay? So now we have 20 over 10 is equal to, well, we're trying to find x, right?
Yes.
So that's side DF. What goes with DF? Look at your similarity statement. AC. Does everybody see it?
Yes.
So AC. So this side and this side are corresponding. Did I go from small to big the first time? 10 over 20. So I've got to stay with that. I've got to go from small to big. So 7 over
X.
over x. Now we're solving for x and we're done. Okay, but pay close attention. We need to cross multiply. Let's get rid of fractions, okay? So I'm going to multiply both sides by x. But what happens over here?
It crosses out.
Divides out, okay? Is everybody following?
Yes.
Do we have questions so far? Okay, then we'll cross multiply both sides by 20. But what happens over here?
This becomes crossed out.
Those divide out. So we have 10 times x
10x.
on the left, which is 10x, which is equal to 7 times 20.
Which is
140. And now to solve for x, what's my last step? Divide both sides by 10. So we get x is equal to 14. So that is 14. Yes. Now, yes, this one was easy to see. Some people were able to see, oh, it looks like we're multiplying by 2 to get from the small to the big. You were right. We were. But they're not all going to be that easy. In fact, most of them aren't going to be. They're going to be decimals, so you can't see it. Yeah.
So, like on this one, on all of them, so if they are like, you said A and B are the same, and you look over and it has 10, then D and E are the same, and that's 20. So would you just put those in fractions and then
Yes.
and then you would
Yes, good. Yep, so the corresponding sides we can set up a ratio. Now understand something, guys. We would have got the same answer if we would have done 6 over 12 instead of 10 over 20. Does that make sense? So we could have used either. One more. Then I'm going to let you work almost. Here we go. Stay with me, guys. Given these two polygons are similar, find the missing sides and angles. So once again, here's our similarity statement. Now this could be flipped and moved around every which way. So we're going to use the similarity statement to determine things, okay? So we know that triangle ABC is similar to triangle EFD. So let's go through this. Let's find the missing angles first. Okay, so angle A, let's find that. Well, what does angle A match up with? E. So find E. It's 88. So what's this? 88 degrees. Questions? All right, let's do another one. We need to find angle C. Angle C matches up with D. So find D. 60. So this is 60. And then once again, angle F is missing. What does angle F match up with? B, and so it's 32. Okay, questions on that? Stay with me, guys. Please stay with me. Okay, awesome. Any questions? This one's a little bit trickier. All right, so now we need to go through and find all the sides. We have 2, 12, and 11. We don't have to find any sides over here. We have 4 blank and blank. So we're going to have 2 blanks to find. I'm going to call this blank X and this question mark.
No, why?
Because they're 2 different things to find.
No, call it y.
Okay, well, we could call it y. I'll just call it question mark. Y question mark, same thing, different thing, right? Okay, so now what we know is if we have similar polygons, we can set up a ratio of corresponding sides.
Yes.
So let's use what we know. We know 4, right?
Yes.
So we're going to need that one for sure.
So
let's do 4 over, we'll check to make sure. DF is to CB, which is 12. So 4 over 12 is equal to, did everybody see why I did 4 over 12?
Yes, I did.
I'm going to say it one more time, everybody look. DF was right here, DF. We know that must be the same as CB. So that's why I was able to tell that those two sides are corresponding.
Will they always give that a similar statement up there?
Yes, most of the time.
Okay.
Otherwise, it'll give you enough information.
What do you? It's it all the time.
You'll always have enough information.
Always.
All right, is equal to, let's find x first. So x over, you've got to use the correct one. So let's check. FE is to BA. So we're looking at BA, so 2. X over 2. Is everybody following? Now we'll solve for x. Let's cross multiply by, is this in the denominator? So let's cross multiply both sides by 2. Is everybody comfortable? I don't write it over here.
Yes.
Because what's going to happen?
It's just going to cross out.
It's going to divide out. Very good. So over here we have 2 times 4, which is
8.
So we have 8 over 12 is equal to
X.
x. Is x already by itself?
Yes.
Okay, somebody do that on your calculator. 8 divided by 12.
It's 0.666666.
8 divided by 12.
Yeah. It's just negative 2/3.
Not negative. I don't know where a negative came in.
Oh, 2/3. I mean.
So 2/3, which is 0.666. Okay, awesome. So we'll round to the nearest hundredth. So 0.66, which is equal to x. I'll also accept 2/3 as an answer. Really, 2/3 is a better answer, but I want kind of both. Does that make sense? So 0.6. Questions on how I got x? 0.66. Let's find question mark. Guys, stay with me. Let's find question mark. Now let's use 4 over 12 again, can't we?
Yeah.
Okay. So 4 over 12 is equal to, and this time we're doing question mark over,
So
11.
11.
so DE,
DE would be CA.
so CA,
Which is 11.
11.
3/4.
So we cross multiply both sides by 11. We divide that over here. So we have 44 over 12 is equal to question mark
3.666.
3.66. Very good. Or
11 over
11/3. Very good. Or 11/3. Very good. I'm not going to write it. I don't remember. Okay, questions on that one. Last one that I'm going to let you work. Okay?
Work forever.
Complete the congruent statement. So we have JKLF is similar to DCBA. Now, you're given the picture. Pictures are tricky. They can trick you. The reason they give you this picture is to trick you, kind of. So I would use the similarity statement. Then it's easy. You won't make errors. Similarity statements don't lie. Okay? So angle J is equal to what angle?
Well,
B. Wasn't that easier than looking up here and trying to? Okay. Let's continue. Angle B
K
is equal to
L.
L. Do we have questions on that?
No.
Okay. KF over CA, which makes sense. Aren't those the same things?
Yeah.
Okay. Is equal to
J L
LF,
L F.
which is LF is over, what is LF equal to? BA. Very good. Last one. So we have CD over KJ. So CD over KJ is equal to question mark over LJ. So LJ.
Is DB or P.
So LJ.
BD.
BD. Very good.
Can there be more than just letters?
No. Well, I guess no. Well, yes and no. You won't see any with 3. But I guess there technically could. You just use your similarity statement. Okay, awesome. Do problems 1, 2, 3, 4. Go. Okay, I'm going to do number 7 with you. Here we go. So it says, identify the similar triangles, find x, and find the measurement of the indicated sides. So once again, we're going to identify the similar triangles here. Then we're going to solve for x, and we only have to find the measure of the indicated sides. So if there's an x on the side, then you'll have to go through and solve, okay? All right, but before we can do that, we have to solve for x. And before we can do that, we're going to set up a similarity statement. So look, guys, I have a small triangle here with a blue angle, a red angle, and a blank angle. Yeah?
Yes.
Okay. Now look at this big triangle. We have a blue angle, a red angle, and a blank angle.
Yes.
So we have all 3 angles the same. These are similar triangles, okay? So let's set up a similarity statement. So I'm going to say triangle. I'm going to go with the small one first. I'm randomly naming it. I'm going to go with AED is similar to triangle. Now this part matters. Your angles need to match up. Angle A was blue. So what should come first? C. And then E was blank on my small triangle. So what's blank on my big one? B. And then after that, D was the 90-degree angle. What's my 90-degree angle on the big one? D. Any questions on how I set up a true similarity statement? Okay, so now we're going to solve for x. We're not going to go through and find all the angles. In fact, we can't. Okay, we don't know what blue angle is or blank angle, but we're not asked to do that. We're asked to solve for x. Well, guys, we have to set up a ratio of corresponding sides to solve for x. So let's set up a ratio here. So I'm going to use 7.2. 7.2 over, you have to set up a correct ratio. Did you hear me? Well, let's make sure. So BC is 7.2. What's the same as BC? EA. So EA is 2.4. Does that make sense? So why you have to check? All my students last hour weren't checking, and they were getting the wrong answers. Okay, so 7.2 over 2.4. Does everybody understand why those two are corresponding?
Because they're the same.
If you look in the similarity statement, they fall in the same spot. Okay. Which is equal to, now before we do this one, I didn't clarify this. From here to here is x plus 1. And then the whole amount is x plus 5. From here clear down to here is x plus 5. Okay? So that picture's hard to draw. So pay attention. So we went from big to small, right?
Yeah.
So we need to stay with that. What's our big side here? X plus 5. So we'll have x plus 5. Now, I'm going to check and make sure I set up the correct one, because it's not always going to be obvious. X plus 5 is that full side. The full side was B to D. So look in your similarity statement. BD, what's the same as BD? ED. So ED. So that'll be x plus 1. Now I'm going to pause. Do we have questions on how I set it up? Okay, what's the question?
Okay, but wouldn't x plus 5 go with BE instead of the whole entire thing?
No, it's just hard to write it. X plus 5 is supposed to be the full amount from B to D. Yeah.
Well, and then what would be B and E then?
B to E, we don't need to know because that's only a piece of the triangle, right? We won't need to know that, but we could find it, but you don't want to. Okay, yeah.
Okay, so you have to see BED.
BED
Okay, between E and D.
is x plus 1. So that's this piece of that triangle. Okay. All right, so are we okay with my ratio?
Yes.
Now let's solve for x. Now look, guys, we have a fraction on the left, a fraction on the right. So I'm going to cross multiply. So I'm going to multiply both sides by x plus 1, putting it in parentheses. But what's going to happen over here?
You have to distribute.
It divides out, right? Now I'm going to multiply both sides by 2.4. So 2.4. But what happens on this side? It divides out. Now, is 2.4 multiplied to the full side? So we have to put that in parentheses. Do we have questions? Yeah.
Well, wouldn't you, since you're dividing all of that by x plus 1, wouldn't you have to distribute all of that?
It will divide out. That's why we cross multiply by x plus 1. What's x plus 1 over x plus 1? It divides out to be 1. Yeah. So now, guys, I'm going to erase this. Is everybody okay if I erase this so I can leave myself room to work? Okay, let's keep going. Now we do need to distribute things through. 7.2 times x.
7.2x.
7.2x. 7.2 times 1 plus 7.2 is equal to 2.4 times x.
2.4x.
2.4x. Don't forget those parentheses. 2.4 times 5.
10.5. No, 10.8.
Do it on your calculator. What? 12. So plus 12. Now, can we magically flow our x's together?
Why not?
No. You have to use the correct operation to get from one side of the equation to the other. So I'm going to subtract 2.4x's from both sides. Combining these, we have 7.2x's minus 2.4x's, which is 4.8x's. Then I still have plus 7.2, which is equal to 12. That added up to be 0. Now I'm trying to solve for x, so I'm going to subtract 7.2 from both sides. So we have 4.8x is equal to 12 minus 7.2 is 4.8. Are you following me, people? Divide both sides by?
4.8.
Divide both sides by 4.8.
It's going to be 1.
So x is equal to 1. We just solved for x. Now we are done with solving for x. It does say, though, to find the missing sides. So 1 plus 1 is 2. So that side's 2. 1 plus 5 is 6. So the full length is 6. Does that make sense? Okay, awesome. Do problems 5, 6, and 8. We're going to do problem number 9 together on the worksheet. So if you read number 9, this is what it says. Sheila is standing near the Eiffel Tower in Paris, France. The shadow of the monument is 580 feet. Now look at my picture. Here's the monument. It's 580 feet is the shadow. Sheila's shadow is 3 feet long. Here's Sheila. Here's her shadow. It's 3 feet long. 3 feet long. If Sheila is 5 feet 6 inches tall, how tall is the monument? So now how tall she is 5 feet 6 inches. And we're looking for how tall the monument is. So I put an X there. So now we're going, yes, they're similar. So we're going to set up a ratio to corresponding sides. Now let me make a point before you start trying to do the math. This is in feet, this is in feet, 5 feet 6 inches. We have two different measurements here, inches and feet. We can't just call this 5.6 feet. That's not true. This is 5 feet 6 inches.
It'd be 5.5.
It'd be 5.5 feet. Very good. 6 inches is 0.5 feet, right? So we need to rewrite this as 5.5 feet. Or we need to convert all of this to inches and then back into feet, which would be way worse, right? All right, so now that we've converted it to make sure we're not using different measurements, we can set up the ratio of corresponding sides. So I'm going to go big to small. So x over what, Brian?
5.5.
5.5 is equal to 580 over 3. Now we're solving for x. So we're going to cross multiply by what?
5.5.
Multiply both sides by 5.5, but on this side it's going to divide out. Now x is by itself, true?
Yes.
So let's do that on our calculator. 580 times 5.5, then divide it by 3.
And 90, and then it goes to 1,603.
Very good, 1,603.3 feet. Now understand, guys, understand something. The 0.3 feet doesn't mean 0.3 inches. You got to convert that. If you're doing it in ACT, I promise you, they will convert it. So how many inches is 0.3? You'll take your 12, multiply it by 0.3. Do it. So this is 1,063 feet, and how many inches? It's 0.3 of a foot, which is how many inches? Do 12?
12 times 6 inches.
And what you did 12 times 0.3?
Yes, 3.6.
And you got what?
3.6.
So 3.6 inches.
What's the tallest?
What?
What's smaller than an inch?
Centimeter? I don't know. I haven't done conversions for that since a long time. Hey, any questions on that? Okay. Do 11, 10, and 11. Go. So now we're going to be asked if two polygons are similar. So guys, we'll check to make sure all the angles are the same, and then we'll check to see if the ratio of corresponding sides is the same. So here's our first problem. Everybody look with me. States of polygons are similar, and what is the scale factor from small to big? And from big to small. So what that means is what did you multiply by to get from the small object to the big? Or what did you multiply by to get from the big object to the small? But first, let's determine, are these similar? You have to check all the ratios. So I'm going to check all the ratios. So we have 5 over 2.5 better be equal to 5 over 2.5 better be equal to 6 over 3, which better be equal to 7 over 3.5, which better be equal to
4 over 2.
4 over 2. Now do that. Actually do that on your calculator. If you do this, you're going to get 2 is equal to 2 is equal to 2 is equal to 2. Now, even if you got 2.01, you would say not similar. One of them is different. They have to be exactly the same.
So if you do all that, if they were all the same, if it equals like a 3/3, it's
Not similar. Throw it out. Yeah, it's not similar. Okay, so we checked it. Now, in all the cases, all the ratios, we got 2. Now, guys, understand something. It's asking us what is the scale factor from small to big and from big to small. Well, we can find the scale factor by taking the ratio. This is a scale factor. Now, let's decide if this is from small to big. Here's a trick for you. Whatever you say second is what you'll put on top. So if we want to go from small to big, which did I say second? Big. So you put the big on top, like I did here. So what's my scale factor from small to big? 2. Now it makes sense, guys. If we multiply 2 by 2, we get 4. 3 by 2, we get 2.5 by 2, we get. So our scale factor from small to big was 2. So then if we want to do big to small, we need to put our small on top, right? What did I say second? Small, so you'll put your small on top. So instead of having the big on top, we'll have the small. So we'll do 2.5 over 5 is equal to 3 over 6 is equal to
5 over 7, 2 over 4.
which is 2 over 4. Then you'll actually do that on your calculator. You get 0.5 is equal to 0.5 is equal to 0.5 is equal to 0.5. So our scale factor from big to small, what we multiplied by here to get to here was 0.5. Does that make sense?
Yeah.
Okay, finish these problems. These in blue highlighted are what are required of you. Okay, you'll want to make note of this. You're going to do extra work. So write this down. You should all be writing this down. So problems 12 through 19 are required. Problems 24 and 25 are required. Bonus problems for advanced thinkers will be 20 through 23. So if you want to push yourself and practice some more, do 20 through 23. But the stuff in the blue is absolutely required of you.